Chapter 5.1, we're looking at nth roots and rational exponents. So the definition of a rational exponent is here. The nth root of a can be represented as n, and then the radical a equals a raised to the 1 over n. So n is what's called our index. And a is our radicand. It's what's inside the square root. And then we have our radical, which is this symbol here. So real nth roots of a, let n be an integer where n has to be greater than 1, and let a be a real number. So n, we're looking at the index here. And so we have n, when n is an even integer, so let me give you some examples of n as an even integer. We can say square root, okay, square root. Now normally square root, when we've seen it before, it does not have an index. So it's assumed if it does not have a number in there that it is a square root. And so that is even. Another example would be like a fourth root. So when a is less than 0 for something inside of a square root or a fourth root, so let me give you an example here. If we had the fourth root of, let's say, -4, so that value inside is less than 0, remember that it's negative and it's not real. Like we could change this as to 2i, but it's really not a real value, right? You're not allowed to have negatives inside a square root. And so it's true for any even integer for our index here. Then if a equals 0, so square root of 0 is just 0. And so we only have one real root. So when it's less than 0, we have no real nth root. When a is 0, we have one real nth root. Now if a is greater than 0, then we have two real nth roots. So plus or minus nth root of a is plus or minus a to the 1n. So let me give you an example. So let's take our 4. So if we looked at x squared equals 4, remember when we solve for it, we square root both sides. And remember when we take this square root, we have the answer of plus or minus 2. And that's because if we plug in a positive 2 squared, that'll equal 4. If we plug in a negative 2 squared, negative 2 times negative 2 is still a positive 4. So that's why there are two real nth roots. So that shouldn't be anything new. It should just kind of be a reminder of the rules when we're looking at square roots. But that applies to any even nth root, so like 2 or 4 or 6. We have to remember that. Now if n is an odd integer, so if the index is odd, like cubed root of some value or fifth root of some value, then we have some rules here. So when a is less than 0, we have one real nth root. Now let me take the example of 8, the nth root of 8, or let's say the cubed root of 8. Cubed root of 8. Now that index, that number 3, tells us how many of each value that we need in order for it to be perfect. So just to kind of back up a little bit again, is if we're looking at the square root of 4, so again, it's assumed that the index is 2 in there. And then so in order for it to come out as perfect, we have to have 2 of some number. And square root of 4, we can change it to 2 times 2. So there's a pair of them. Therefore, this is just 2. So when we have an index of 3, then we need 3 of them to be perfect. So if we have the cubed root, let me go back, cubed root of -8, okay, so we need 3 of a number and it has to be the same. So cubed root of 8 can break down to 4 times 2, or really that's just 2 times 2 times 2. Now it has to be the same sign in everything, so we have 3 negative 2's, because -2 times -2 is a positive 4. 4 times -2 is a -8, so that gets us the value here. And so when we have a negative, we will get one value, and the answer will just be -2. So that is why when a is less than 0 for a cubed root or an odd nth root, that we will get one real value, and that'll be negative. Okay, so just like this, cube root of -8 is a -2. So we get one real nth root. Now it's the same for 0. If we have a cube root of 0, that'll be just one real root, which is 0. If we have fifth root of 0, that's still 0. Now if we have a is greater than 0, so let's just take 8 again. If we had cube root of 8, in order to do that, we can have 3 2's, right? 3 2's, and so our answer would just be 2. We have one real value. So that's the difference between even and odd. Odd, we will always just get one real nth root. For even, we have to be careful. So if it's less than 0, if it's negative, then there is no real nth root. If it's greater than 0, then we're going to have 2. So that's the biggest concept that we need to take away there.